Today, we will perform a lab entitled Reversible Reactions, which is going to demonstrate Le Chatelier's principle, which simply says that an equilibrium will shift in response to a stress imposed upon it, either to the left or to the right. Today's lab will have three parts A, B, and C.
For part A of our experiment, we will be adding a very concentrated 12 molar hydrochloric acid into a saturated NaCl solution and a saturated NH4Cl solution, and we will observe the results. You can see the reaction in both test tubes, that a white solid was formed in each. For part A of our experiment, we were dealing with the solubility of sodium chloride and the solubility of ammonium chloride. These were both saturated solutions, which means that we had the most possible sodium and chloride dissolved in the solution. The same thing with the ammonium chloride. So these are the two equilibria that you will use for your lab analysis. For part B of our experiment, we have three different test tubes, and each test tube has a mix of iron 3 thiocyanate and iron 3. This ion is very dark red in color, and the iron 3 ion is more orange. So you can see that the combination gives this original color. We're going to add potassium thiocyanate to test tube 1. We're going to add iron 3 chloride to test tube 2, and we're going to leave test tube 3 as a control, and we're going to see if there's any color change. So here I will add potassium thiocyanate to this test tube. There is a little bit of a darker color, as you can see. Hopefully you can see that well on the screen. It is darker, more of a reddish orange. And then we're going to add some FeCl3, which is also actually orange, as I said, like the iron 3. And let's put that into here and see that color change. That one is definitely more obvious, but hopefully you can tell that both of these test tubes did get darker than the original control test tube. Over time, you can actually see that these three test tubes do look very different, and the one on the right is your control, and the one on the left, both of them on the left, have become much darker in their orange color. For part B of our experiment, this was the equilibrium that we saw, and we have to note that the FeSCN plus 2 ion is really more of a deep red color, and the Fe plus 3 is more of an orange color, and the SCN minus ion does not have a color, it is colorless. So referencing these colors, you can determine which way the equilibrium shifted when you added the different other solutions. In this part of the experiment, we start with simply some NH3 ammonia in this test tube. Now ammonia reacts with water to form ammonium and hydroxide. Hydroxide makes things basic, as we know, and so what we're going to do is use an indicator, phenolphthalein, to show the presence of the hydroxide, which makes the solution basic. So I'll put 1 drop of phenolphthalein in here, and you will see color turns pink. That is the characteristic color of a base that has phenolphthalein in it. Now what we will do is we're going to add HCl, hydrochloric acid. We're actually going to add a 6 molar hydrochloric acid, which is pretty concentrated, and this is going to shift the equilibrium because hydrogen in the H plus in hydrochloric acid reacts with OH minus to remove it and form water. So what we're doing is we're removing hydroxide from this equilibrium. So let's see what happens when we add some HCl to this. Take it out and give it a little swirl. And you can see that the color has completely disappeared. There's a lot of steam going on in there because this is a 6 molar hydrochloric acid, so it's very concentrated. So it does that with the water. So you can see again that the phenolphthalein disappeared because we removed all the hydroxides with the H pluses to form water.
Here is a picture of our final results with each of the test tubes labeled.